Hello viewers, welcome back to my channel. In this video we will see about first order chemical kinetics reactions, integrated rate equation of first order chemical kinetics reactions. First we will see about the definition of first order chemical kinetics reactions. First order reactions means the reactions in which rate of reaction is proportional to the first power of the concentration of the reactants are called first order reactions. I am repeating, the reactions in which rate of the reaction is proportional to the first power of the concentration of the reactants are called first order reactions. Here rate of the reaction is proportional to the first power of the concentration of the reactants. That's it. Very simple definition. The reactions in which rate of reaction is proportional to the first power of the concentration of the reactants are called first order reactions. Simply rate is directly proportional to the first power of the concentration of the reactants. Here reactants is converted to product. Initial when T is equal 0, R is taken as R naught, initial concentration of the reactant. Immediately product will not be formed at time t. Concentration of the reactants is R. Then product concentration is P. Square bracket indicate the concentration, molar concentration of the reactants and products. Here, as per the statement, rate of reaction is directly proportional to the minus dr by dt represent the rate of the reaction, first power of the concentration of the reactants. Here, square bracket indicate the molar concentration of the reactant. R power is nothing but 1. R power is 1 is nothing but 1. R power is 1 means R only. Remove the proportionality and put the constant K minus dr by dt equal to K into K into R. Here K into R minus dr by dt equal to K into R. Multiply with minus 1 in both sides, then we will get what we will get minus dr by dt become a plus dr by dt, dr by dt. Here this side minus is not there. Here minus is not there. Only left hand side having minus. Okay, here kr become a minus kr. Transpose the r to r from right hand side to left hand side. Here multiplying, if it is comes to this side, divide. Similarly, transpose the dt to this side. Here dividing, if it is comes, multiply. Therefore, we can write that dr by r equal to minus k dt. Okay, this equation. In this equation, we have to do the integration. This equation we can write in the form of here dr by r we can write 1 by r into dr. Similarly, minus k into dt. Here, for this we have to integrate on both sides. In this equation, in this expression, we have to do the, in this mathematical expression, we have to do the integration on both sides. Integration on both sides. The general formula for 1 by x 1 by x integration 1 by x into dx equal to logarithm of x. Similarly, integration 1 by r into dr is equal to, similarly 1 by r into dr. Here r is enclosed in a square bracket. Logarithm of r. Write this data by using this general formula. Write this data in this equation. In the place of 1 by r dr equal to logarithm of r, we can write that ln r equal to, similarly here k is there, minus k, minus k is there, k dt, integration minus k dt. Similarly here minus k as it is, integration another formula is there, integration dx is equal to x. Similarly integration dt equal to t. Similarly integration dt equal to t. So this data we can write in here, integration 1 by r into dr is equal to ln r. Here minus k as it is. Here in the place of integration dt we can write that t minus k t plus, whenever we are doing integration we have to put the constant called as integration constant high. Okay, this is equation 1. Next, when t is equal to 0, r become a r naught. Initial concentration of the reactant r become a, initial concentration is r naught. Put this data in this equation. In the place of r we can write r naught, indicate initial concentration of the reactant, minus k into, in the place of this data we are applying in this equation. Okay, here in the place of t multiply with 0 plus high. Okay, here simplify, minus k into 0 means 0 only. Therefore this expression ln r naught equal to high. Equation 2. Substitute the equation 2 in equation 1. In the place of high we shall write ln r naught. In this expression in the place of high we can write that ln r naught. Therefore ln, equation 1 become ln r equal to minus kt plus I. In the place of I we can write that ln r naught. Transpose the ln r naught, transpose the ln r naught to, from right hand side to left hand side. Therefore ln r minus, here it is a plus quantity, if it is comes to this side become a minus quantity. Ln r minus ln r at equal to minus kt. In this equation now multiply with minus 1 in both sides. Therefore the minus quantity become a plus, then plus quantity became minus, here minus quantity become a plus. Ln here r naught is there, ln r naught, ln r naught minus ln r equal to, here minus quantity become a plus, plus quantity become a minus, this minus quantity become a plus, equal to kt. Okay, log a minus log b equal to, general formula log a by b. This is in the form of log a, this is in the form of log b. Okay, here if you apply this formula, ln r naught divided by R ln R naught divided by R equal to KT. Then assume equation 3. In this expression, transpose the t, which is multiplying here, to this side. Then therefore we can write that k equal to, here multiplying, if it is comes to this side, here this side to this side, transposition upon transposition, here divide k equal to 1 by t into log r naught divided by r. Another formula is there, mathematical formula, ln r equal to, here whenever you removing ln and put the log, log means, for that we have to multiply with 2.303 into log log. Okay, here in the place of ln r naught, we can write this expression, ln r naught equal to 2.303 into log r naught. This expression we can write here k equal to, by removal of this, we have to put the 2.303 by t as it is into log r naught divided by r. Okay, this is the final integrated final and integrated rate equation of first order kinetics. In this, k is called as rate constant of first order, rate constant of first order reactions. T is the time of reaction. R naught is the initial concentration of the reactants. Initial concentration of reactants. R is the concentration of the reactants at time t. Okay, this is the first order chemical kinetics. This formula is called as first order chemical kinetics rate equation, integrated rate equation. In other books, this NCERT version I am taken from NCERT book. In another private publication books, this same formula can be written as k is equal to 2.303 divided by t into log a by a minus x. Okay, this is the same formula. This formula also represent this formula. This formula and this formula both are same. This formula is given in NCERT textbook, NCERT book. This formula is given in this type of formula is given in private publication books. Private publication books. This formula is given in private books. Don't confuse. In the place of R, A is taken. Here A R, here R naught represent initial concentration. Here R A minus X represent the concentration of the reactants at time t. Okay, if you repeatedly, if you revise this, if you read, if you go through this my video repeatedly, then I hope that you will get a very good knowledge to join in IIT as well as good medical colleges like AIMS. Okay, or if you are willing to join in a good medical college like just like AIMS Delhi campus, or if you want to join in a good IIT colleges like IIT Kanpur, IIT Guwahati, IIT Delhi, IIT Mumbai, IIT Madras, like old IITs. My videos are very much useful. You will repeatedly you will watch my videos and add a positive comment, okay, and share to your friends and subscribe my video, subscribe, share and like my video and add a positive comment. If you want to ask some questions, you can add also. I will reply for your questions. Okay, thank you very much for your watching my videos.